Okay, last time we started to talk about the node voltage method and explain how we can start to analyze a general circuit in any form using the node voltage method. And we did some examples. So we're going to start to talk about the node voltage method further. So the one example, let's look at an example again. Here, if we have a circuit look like this, node here, and there's a current going here. So 3.5 amp, and then have this 4 ohm here, there's 5 here. And then have another 5 ohm here. And so there's a node here, there's a node here. So 2.5. So 10 ohm here. And then we have another source here, so 2 amp. Also, these are our nodes. So assume this is what we have. There is a circuit giving us like that, and then we are asked to start analyzing it using the node voltage method. So one of the very first things that we need to do is we have to find the reference node. So the reference node, as I said, or like a ground connection, we consider the node that it's going to be zero. We consider voltage at that node 0, and then we calculate all the voltage compared to that reference node. So to do that, again, I said here, most of times easier to get it somewhere down here. So if I come here and I said, this is where I get the node voltage. Look at here again, between this node here and this node here, there's only a wire. So these two nodes are essentially the same. So that there's no difference between the node here and the node here. I can put them on top of each other and just remove this wire, because there's only a wire between them. So it doesn't matter if I choose the reference node underneath of this one or underneath of this one or somewhere between these two. This whole area is just behave the same. So for example, if I go back and put the reference node here, that's okay. If I go and put the reference node here, that's okay. And if I put the reference node between them, also is okay. And all these three conditions are going to be the same. So there's no difference between putting it here, putting it between, or putting it here, because basically there's only a wire. I can put these two nodes on top of each other. After that we have this one, we, as I said, that let me name them. So for example, this is the V1, this is the node 2, this is the node 3, and then we can consider this one as down here as a node number 4. And as you can see, again, these 4 and this one also gonna be 4 because these two are the same. So the first step, we define the reference node. The second step was that we will go ahead and assume that at each node, all the current leaving that node. So we know that the current here leaves, current here leaves, current here leaves. So for example, if I name this one, current goes from 1 to 2. It's simple. This one, I just call it I1, just to make, don't get confused with the other one, because both of them goes from 1 to 2, and this one goes from 1 to 4. The same here, if I go to the second node, then I said I assume all the current leaves that node. So it's going here, it goes I. Again, I call it I1 because it's going to be the same as this one. This one's going up, it's go from 2 to 1. So it's going to be I 2 to 1. And this one goes from 2 to 4, so it's going to be I 2 to 4. And this one goes from 2 to 3, I 2 to 3. And here, also let's make this I2, so to make it a little, don't make it confusing. This one, make it so this one is I2. So, and then for the third one, we have the one is going from 3 to 2. We have one current goes from 3 and eventually to 4. And then again, this one I just simply call it I3, because this one is also go from 3 to 4 eventually, but just make sure they're not confusing. So after we define this one, and I don't put it there, but in respect to the reference point, all the voltage will consider the positive respect to the reference point. So the V1 is positive respect to the reference point negative. V1, V2, and V3 are positive. The reference point is negative, and the other are positive. Then we start to write the Kirchhoff current law at every point. So at, for example, at node 1, we know that the Kirchhoff, this way. So we write the Kirchhoff current law at node 1. And what it says is, it says that if I add all the current, it should come 0. So if I start to write it at the node 1, I know that it's going to be these two. So it's going to be I1, 2 plus I1 plus I1, 4. If I add them, it should come 0. These 4. Now, if I go ahead and write them as a form using, sorry, what is this? This one is so it's going to be I1, 2. And then if I replace them with the voltage and the resistance for the I goes from 1 to 2, so it's going to be V1 minus V2. So start from the end, subtract the start from there, divided by the current I have, the resistance I have, so divided by 4. And then I have the I1. The I1, I already know that. So in this wire, I already know the I1. I goes from V1 to V2, and the magnitude of that is 3 amp. So I already know that, so I don't need to replace it with anything, just put the values for that I1. And then when it goes from the 1 to 4, again, we have the V1 minus V4. And if I divide that by the resistance between them, it's going to be 5, and it's going to become 0. So then we have the KCL at node 2, and again says that if I add all the current going in and leaving out the node 2, should comes at 0. So at node 2 I have I21 plus I2 plus I23 plus I24. So I21 is going from 2 to 1, and there's going to be V2 minus V1 divided by 4 plus. The I2, we know that the I going from the node 2 toward node 1 is 3.5 from the left to the right. So the I2 is in the opposite of that 3.5. So we are going to put the negative 3.5 here, because the I2 is in opposite direction of that. And then we have the goes from the because the 2 to 3, so it's going to be V2 minus V3, V2 minus V3, and there's a 5 ohm between them. And then V2 minus V4, it goes from here, so it's going to V2, and the V4 we know is 0, so also here is 0. I can put 0 here. I don't need to write it. So the V4, because it's the reference node, is 0. So it's going to be V2 minus 0 divided by 2.5. It's going to be 0. And then we can write it for the third node. So again, the KCL at node 3. And again, the sigma I is 0. And at node 3, we have I goes from 3 to 2 plus I3 plus I goes from 3 to 4. It's going to be 0. So the one goes from 3 to 2 is going to be V3 minus V2 divided by the resistance between them, which is going to be 5. And then it goes I3. If I look at the I3, I already know the current in this wire. It should be 2 amp, and it's going in the opposite direction of the I3. So the I3 is negative 2. So the minus 2. And then plus the one goes from 3 to 4, which is going to be V3. And the V4 we know is 0 because of the reference point. And the 10 ohm here. So this is going to be our 3 equations. So we have V1, V2, and V3. So we have 3 unknown and 3 equations. So if I can go ahead and write these 3 equations in the sets of equations. For example, if I just for the V1, I can say it's a 1/4 of V1, and then I have plus 1/5 of V1. So it's going to be 1/4 plus 1/5 V1. For the V2, we have only 1/4 V2, and then we don't have V3, so it's going to be 0 V3, and then we bring 3.5 to the other side, so it's going to be negative 3.5. Then the second equation, we can write it again for the V1. We have only one term of the V1, so it's going to be negative 1 V1. For the V2, we have 3 terms, so it's going to be plus 1/4 here, then 1/5 here, and then 1/2.5 here, V2. And for the V3, only we have one term, which is going to be this, which is V3. And then if we have any constant, we take it to the other side. So if we can take it to the other side, it's going to come out at 3.5. And the very last equation, so we don't have any V1 in that, so it's going to be 0 V1 plus. For the V2, we have only one term, So it's going to be negative 1 over 5 V2. And for the V3, we have two terms. So it's going to be 1 over 5 plus 1 over 10 V3. And then take the constant to the other side. So it's going to be negative 2. And if we want to write it as a matrix format, so it's going to be just the coefficient of V1, V2, or V3. So the coefficient of V1 is 1 over 4 plus 1 over 5. And then we have the coefficient of V2 is the negative 1 over 4. And then we have 0. And here we have again coefficient of V1 is negative 1 over 4. The coefficient of V2 is 1 over 4 plus 1 over 5 plus 1 over 2.5. And the coefficient of V3 is negative 1.5. Negative 1 over 5. And then here the coefficient is 0. Is again negative 1 over 5. And the V3 is 1 over 5 plus 1 over 10. So these are the coefficients. Then the unknown is V1, V2, V3. And the constant here, constants are negative 3.5, 3.5, 3.5, negative 2. And so you can easily enter these coefficients into your calculator and then solve it for the value of the V1, V2, and V3. So if I write everything right, the V1 should come out as negative 5 volt. V2 should come out at 5 volt. And V3 should come out at 10 volt. So this is how we solve this. And by the time when we have V1, V2, V3, we can use either of these equations. If we need any of the I want any of these current, we can just use any of these terms to calculate that I. For example, if I want to calculate I goes from 1 to 2 here, I just substitute V1 and V2 here, and that's the I goes from 1 to 2. And for any other I values, I can just use the corresponding term for that I and find the I if I need to find the I. Yes, it should be positive 2 here, and then it should be positive 2 here. Now I'm gonna start to talk about so far all the examples we did, it was the current source in the circuit. Now I'm gonna start to look at what if we have a voltage source in a circuit, and yeah, it makes it a little bit more complicated when we have the voltage source, but it's not that bad. For the voltage source, so this is that here. So if I want to write a node voltage for the circuit that has the voltage source, see how we can do the work there. So let's look at an example, and I will explain it on the example. So assume we have a source here, the current source is a 1 amp, and then goes up here, connected to resistor. It's a 2 ohm resistor, and then we have another node here. So, and then we have a source, the battery source here, and it goes to it's a 10 ohm, and then it comes to 5 ohm here. And then we have on the very top, we have 5 ohm. It's going to be 5 as well here. So we have one node here, and we have another node here. We have one node here, and we have one node down here. I want to do the calculation for this. So again, the very first step that we need to do is just define a reference node. And as I said, most of the time, the one is closest to the source or the one is down here is the easiest one to choose at. You can choose any other one, but they choose here. There's a reference node. So this one, as if I call it the node 4, so I'm going to put the voltage here. So it's going to be V1 here. It's going to be V2 here, and call this in the middle one as a V3. So V3 here, and this is the fourth node. And then we'll go and assume that all the currents leaving the, for every node, we assume all the current at that node leaving that node. So it's going, for example, here goes from, I goes from 2 toward 3. I from here goes from 2, sorry, it's 1. Goes from 1 toward 3. Up here goes from 1 toward 2. And down here goes from 1 toward 4. Same here, we have the I goes from 3 toward 1. Here goes from 3 toward 4. And then we have this one goes from 3 toward 2. And the same here, you have the V, you have the I goes from 2 toward 3. You have the I goes from 2 toward 4. And we have the I goes from 4. And we have the I goes from 2 toward 1 from top. Then we have to start to write the KCL at every given node, and then we go ahead. So let's start to write a KCL at 1. So KCL at 1, which tells us that the sigma I should be 0, and therefore if I have I goes from 1 to 2 plus I goes from 1 to 3 plus I goes from 1 to 4 is 0, and then I goes from 1 to 2 here. It's going to be V1 minus V2 divided by 5. And then I goes from 1 to 3, which is goes from here to here, so it's going to be plus V1 minus V3 divided by 2, and then it goes from V1 to 4. We have the current source here, so we already know the current in this wire is going to be 1 amp, and we are moving against that in the opposite direction, so it's going to be negative 1. That's going to be 0. Now I will write the KCL at point 2. Again, at point 2, sigma I should be 0. So I goes from 2 to 1 plus I goes from 2 to 3 plus I goes from 2 to 4 should be 0. So it's going to be V2 minus V1. The 1 goes from 2 to 1, and there's a 5 volt resistance. Goes from 2 to 3, so it's going to be V2 minus V3 divided by 10. And then here it goes down here, so it's going to be V2, and this is the reference point minus 0. So V2 minus 0, and then we have this one is 5 also, so it's going to be 5. 0. So this is the 1, this is the 2, and then we have to write it for the so in these two equations, if you look at it, I have V1, V2, and V3. V1, V2, V3. I have 2 equations, 3 unknown. I need a third equation. Now, if I look at for the third one, and if I want to write a KCL at the third one, see what happens. So I'm going to write, if I want to write is sigma I is 0. So I'm going to have the I goes from 3 to 1 plus I goes from 3 to 2 plus I goes from 3 to 4 is 0. And if I want to write the equation here, so 1 goes from 3 to 1 is going to be V3 minus V1 divided by 2. And then I have the 1 goes from 3 to 2 is going to be V3 minus V2 divided by 10. And then if I want to write the 1 goes from 3 to 4, I have V3 minus at 4 is 0. And then what should I use here? Because it should be voltage, the difference in the voltage divided by resistance. And then I don't know how much is the resistance here in that battery. So I don't know that term. So I don't know what is this. And it should be 0. The problem is that this, because I don't know that value here, I cannot use this equation. Basically, this equation is useless for me. Because although I add one more equation, I'll add one more unknown. This is not going to help me to do anything. So that's the problem when we have the battery in the system. We cannot write the KCL anymore. If you have the battery, we don't know how much we don't have any way to write the current formula going through that wire because of we don't know the resistance of the battery. In those cases, usually we have to look for another way. You have to find another equation. So the KCL is not going to help us, and we have to find another one. Here, for example, so in every case, you have to look at your, I would say, look at your circuit and try to figure out what is the, how you can get the additional equation. In this case, it's really easy. If you look at it, the V3 is connected to the positive sign of the battery. And the V4, which we write the V3 minus V4, if you look at it, V3 minus V4 is basically the battery voltage. So if I have the battery voltage here, which is going to be 10 volts, because this is 0 here, I assume the voltage as 4 is 0. So V3 minus V4, because these two nodes are connected to the both other side of the battery, these two are actually the battery voltage that that we have. Remember when I said that if we have the well, if we move let's say remember when I said if we have the battery and we move toward from the this is a V1, if this is a VS, and this is a V2, and we go from the V1 to VS, if this is, we are moving from this direction, then the V1 plus VS is going to be V2. Remember that we have that. And also I say that if you have the, oops, negative, positive, V1, V2, Vs, and we goes from, this time we're going from this direction. Then this time V1 minus Vs is going to be V2. So in simple word, if you look at this, is that V3 and V4 connected to the other side of the battery. So V3 minus V4 should be exactly equal to the battery voltage. So, and V4 is 0. So therefore V3 is just 10 volts. We already know that because it's directly connected to battery and the other end connected to the sources. So in this case, we directly can find the V3 as 3. In future, if you have any problem that has the battery and one node connected to battery and the one end of the you have a battery, one end connected to node and the other end connected to the source. This is the important. The other end should be connected to the reference node. So if one end connected to reference node, then the voltage of other ends is equal to voltage of battery. One more time. If you have a battery that one end of that connected to the source, connected to the reference, the other end, the voltage at the other end is equal to the voltage of the battery. And this is the case we usually get. And because we are the one who choose the reference node, try to choose the reference node that helps you to do that. So I choose the reference node here at one end of the battery intentionally, because by doing that, the other end of the battery, the voltage is going to be exactly the same as the battery. If I chose any other node, for example, if I chose the reference up here or the reference here, then I could have not done that. But because I chose intentionally, I chose the reference at one end of the battery, the other end has the same voltage as the battery. So it gives us, so we find the V3 is 3, and then we have these two equations. So we have equation 1 here, we have equation 2 here, and then we have these 3 equations. And if we solve these 3 equations together, or other word, substitute V3 in these two, then you have 2 equations, 2 unknowns, and you can solve this to get the V1 and V2. So if you solve these two together plus the V3, so it's going to tell you how much is going to be V1 and how much is going to be the V2 values in this specific configuration that we have here. Remember when we have the Ohm law, it says if this is the R and this is the VR, we would say, and there's a I, we say that VR is IR. What is the VR? The VR is V1 minus V2. VR is V1 minus V2. Doesn't matter how we reference them, as long as we know the difference between them, we can use the Ohm law, and this is exactly what we use here. We just use the difference between every two nodes across the resistor. So as you see, again, if we have the battery in the system, is one of the battery, try to choose the reference node in a way that one end of the battery be on the reference node. So it just helps you to get the other end equal to the voltage, to the whatever the voltage the battery has. If it is doable, unfortunately, in some cases you cannot. Unfortunately, in some cases, the battery might be in a location that you cannot do that, or maybe you have 2 batteries in the system. So if you have, for example, 2 batteries, you may get the reference node at one end of one of the batteries, but what you are going to do with the other battery? If you have only one battery, so as I showed in the previous example, it's easy. You just get the reference node at one end, what end of the battery, and the other end of the battery is equal to battery voltage. If you get it at the negative side, I'll do. If you get the reference node to the negative side of the battery, then the other side of the battery is going to be equal, the voltage in the other side of the battery is equal to the battery. But it might not be doable in all cases. And I will, for example, let me show you an example here. So assume I have this. Then I have this, other resistance here. The resistance here. Now the resistance here. And then assume there is another battery here. It goes from negative to positive. And then we have this. The node we have is going to be V1 here. We have the V2 here. We have the V3 here. And there's another node here. R1, R2, R3, and R4. So assume this is what we are given, and we have two batteries in the system, and we know that when we have the battery, we cannot write the KCL for the node connected to that battery, because there's a battery here. If we want to write the KCL for that, because we don't know the resistance of the battery, we are going to have a problem. So I assume this one is a problem. So as a solution that we had in the previous one is that get the reference node at one end of the battery. So I can, here I have two batteries. So first of all, let's deal with this one. So I have to get the reference node to at one end of this battery. I either can get it here, or I can get it here. So I can get the reference node here, or I can get the reference node here. So if I put this one number 4, if I put the reference node at V3, okay, then V3 is going to be 0, and V4 is going to be equal to 15 volt because it's connected to positive side of the. If I put the reference node here, then V4 is going to be 0, and V3 is going to be negative 15 because it's connected to negative side of the battery. So I can either choose the V3 or V4 as a reference. Now assume I choose it here. So assume I choose the reference node here. So the V4 is going to be 0. The V3 connects, so if I come here, the V3, because one end is connected to the reference and the other one is connected to V3. V3 is equal to the battery, but because it's connected to negative sign of that, it's going to be negative 50. Like that. Now let me just show you if I do the other way how it's going to happen. So if I choose the V3 as a reference, so I assume I choose the V3 as a reference, then the V3 is going to be 0, and V4 is connected to the positive sign of that, so then V4 would be 15, plus 15 because it's connected to that. So I either can get the reference at V3 or I can get it at V4. If I get it at V3, it's going to be 15 volt because connected to positive. If I get it at V4, it's going to be negative 15 because connected at that. So I do it the other way, so you also be you have example for this one as well, so you know if it's connected to negative, it's going to be. So V4 is 0 if I get it here, and V3 is going to be negative 15 because it's connected to the negative side of the battery. So that helps us. So we don't need to be worried about this node anymore because we know the voltage at that node. Then we have the V1 and V2, and V4 is the reference, is 0. V3 is negative 15. We know that. Now what we are going to do with this one, with this voltage here, because I already choose it, the reference node, and it's not going to be at any end of these two. And I don't know the resistance in that, so I cannot write the Kirchhoff current law neither for V1 nor for V2. I cannot write it for any of those. If you have the battery, again, if as I said, if you have a battery in this system, and if you put the, what's that? If you have a battery and you put the reference here, it's a VS, V1, V2. If you have a battery, if V2 is connected to the positive sign, or V1, VS. If you have a condition like that, the V2 is VS. If you have a condition like that, positive yes, V1, and then have this reference, this one, the V2, negative. Just remember that if it's connected to the positive sign, it's going to be positive VS. If it's connected to the negative side, it's going to be negative VS. Sorry, negative VS. It's going to be negative VS. So here again, so I connect this one to, so I choose the reference here. The other one is connected to the negative side. So it's going to be negative 15 here. Now I will come here for this one, and then when I want to deal with these ones that I don't have reference on either of these two, can write the KCL for, I cannot write a KCL for V1, I cannot write a KCL for V2, and then it's going to be a problem. To do that, what we do is the method that we call the supernode. In other words, what the supernode is that I would consider the entire part of the circuit as one node. Instead of looking at the single node, I choose a region in the circuit as a node. And then I would say all the current goes into that region should leave that region. Instead of saying that all the, what we say in the KCL, in the regular KCL is that if I have a node, I have everything goes in, should leaves out. That's what we say in the regular KCL. Now assume I choose the region of the circuit, that there's a couple of nodes in that, for example. I would say whatever goes into that region, or put it downward, whatever goes into that region should leave that region. This is the node. This is going to be called supernode. The supernode, in the simple way, you select part of the circuit and you say that whatever goes into that part of the circuit eventually should leave that part of the circuit. So to deal with the cases that we have the batteries and we cannot put a reference on either of that battery, to deal with that, what we are going to do is that we'll say, okay, this is going to be a supernode. And where's going to be a supernode? I would say that you put the battery in that. So let me make it a little bit smaller so it's easier to. So this is, I would say this is my node. Instead of V1 or V2, I said this whole area, the green area, this is my node. And because this is my node, now I would say everything goes in that node should leave, every node goes in that region should leaves that region. In other words, everything goes in that super node should leaves that super node. And the same as what we had before the previous steps, that we consider every node and assume all the current leave the node. Now here we assume all the current leave the super node. So if this is my region, every wire connected to that region has the current. So I would say that I have the current goes from here to here, from V2 to 3. This one leaves that region. Also, I have the one goes from V2 to 4. This one also leaves that green region. Here also I have the V1 goes toward V4. This one leaves this green region. Also, this one here leaves the green region that goes from V1 toward V3. So I have 3 wire goes out of that region. So that's why everything, if I everything in that region should come there. Now I can write the KCL for entire this super node without I need to deal with the this battery. In that case, it helps me to, so instead of writing that the KCL for each node, I would write the KCL for super node. And in that case, is like that. I would say that, oh, these are I, sorry. I write them V. Let me go back and correct them. So these are going to be I, sorry. So it's going to be I goes from 2 to 3. It's going to be I goes from 2 to 4. It's going to I goes from 1 to 4. And there's going to I goes from 1 to 3. So these are the current leaving that super node. And then if I write the KCL at super node, what I have is that I have all the I should comes as 0. So then I would have I goes from 2, 3 plus I goes from 2 toward 4 plus I goes from 1 to 3 plus I goes from 1 to 4. If I add all of them, it should come 0. And this is the equation eventually I'm going to use to solve my problem. So this one, when I wanted to write it, so I goes from 2 to 3 is going to be V2 minus V3, 2 to 3 divided by R3. And we know already V3 is negative 15. Then for I goes from 2 to 4, it's going to be V2 minus 0, because 4 is the reference, divided by R4. So it's going to be V2, 3 is R3. And then we have the I goes from 1 to 3. It's going to be V1 minus V3 R1. And then what we have here, V goes to 4. It's going to be V1 minus 0, because the reference is 0, divided by R2. And this is going to be 0. And we already know that the V3 is negative 15. The V3 is negative 15. So and this is how we write that equation for that specific node. And in later, when we have the example with the number, I will show you how to solve the entire circuit. But for this one, just the only point is that I want you to know how to write the KCL for that specific node here that we want to write it, so you can have that. supernode there. So this is how we actually use the supernode in case that we have the voltage sources in the circuit that we cannot put the reference node at one of its ends. So here, if you look at it again, I have just very quickly to say what we will do. We have the V3 is negative 15. Then we have these equations that gives us V1 and V2 and V3 we have it. So we have two unknown here and one equation. And we need, as I said, we need another equation in order that we can solve this problem. So because we already, the V3, we cannot use it, that node. With this node also we use it. So we used already all the nodes we have. We use V1, V2, V3, and V4. So there's no other node left that we can use it. In those cases, again, as I said, you have to go and try to find another equation in the system to use it. Here, for this specific example, that I can go ahead and look at this. If I write V1, and then I have 10 volt, and then I have V2, then I can write the equation between V1 and V2. It says that if I go look at like that, it goes from negative to positive, so I can say that V1 plus 10 is going to be V2. And it's going to be our additional equation that we have it for this specific case that we have. It gives us the another equation with V1 and V2, and we know the V3, and then we have this equation here, which get it from the supernode, and then we have this equation that simply just write it between V1 and V2 at both sides of that battery. This equation, and this value here helps us to solve this entire problem if we had the values for them. Now let's look at an example to see how actually we will work with them. So I have a battery, the source, the current source, so it's going to connect it here, Then we have one resistance here, one resistance here. We have one resistance here. Connect them all together like that. And this is we want to solve these problems. So it's going to be R1. It's going to be R1. It's going to be R2, R3, R4. That's going to be 10 volts, and it's going to be 1 amp. And we want to we want to solve this one. So again, the very first step that we are going to do was that we have to choose the reference point, and we can choose it at any of the nodes. So we can choose it there. In this case, I can choose it here at very down here, the reference node, and then do the address, everything else with respect to that. I can choose it here at one end of the battery, and then find the voltage at the other end, or I can choose it here. Or I can choose it at the middle. So it doesn't matter where you choose it, then you are gonna find everything else with respect to that. Probably one of the easiest way of doing that is just getting it right here. So this one's gonna become 0, and this other end here the voltage at this end is going to be -10 because it's connected to that. But let's do it the other way. This time I just don't follow the book. The books want to get the reference node here. So I get the reference node here, and this is going to be the 0. Then we have the V1 here, and the V2 here, and the V3 here. I want to write the equations for this specific circuit. So when we want to write it, because we didn't get a reference node to the battery, we cannot write it. We cannot find any values for V1 or V2 because they're connected at both ends of the battery. We don't know what's happening in between them. So we cannot write anything for the V1. We cannot write anything for the V2 because they're connecting to the battery. And then we have the V3 that is going to be here. So and it's going to be V3, which is our reference. I cannot write anything for V1. I cannot write anything for V2. But to solve it, what I need to do is that I have to go and make them a supernode. So I would grab these two together. So because they both connected at the both sides of that battery, so both of them with the battery, I consider them as one node. And then I would go ahead and say the current goes here, which is going to go from 1 to 3. And then I have the current leave that supernode from here. It goes from 1 to, sorry, this is 3. Let me make it on the book called this one 3. Oops, this is a V3. And let's consider this one 4. So, yeah. So this one goes from 1 to 4. So this one goes from 1 to 4. This one goes from 1 to 3. Then we have the current goes from here from 2 to 4. And there's a current goes here from 2 to 3. So if I write the KCL at supernode, what I have here is the sigma I should be 0. So therefore, I1 3 plus I1 4 plus I2 3 plus I2 4 should become 0. And then if I substitute them, so for the I goes from 1 to 3 is going to be V1 minus V3 divided by R2 plus the 1 goes from 1 to 4. Going to be V1 minus 0 because we choose the node 4 to be reference. So V1 minus 0 divided by R1 plus I goes from the 2 to 3. So it's going to be V2 minus V3 divided by R3. And then goes from 2 to 4 is going to be V2 minus V4. Sorry. And this one is connected to the current source. We already know the current in that wire, and the V24 is in the opposite direction of that, so it's going to be -1. It's going to be 0. So that's the equation that we can write it at this node here that we have. So you have the V1, V2, and V3. So there's still we have 3 unknown and 1 equation. Then we can go ahead and write the KCL at point 3. So if I look at the KCL point 3, I have the I goes from 3 to 4, I goes from 3 to 2, and I goes from 3 to 1. I have these three I's. So sigma I is 0 at that node. So I have I goes from 3 to 1 plus I goes from 3 to 2 plus I goes from 3 to 4 should be 0. And so 3 to 1 is going to be V3 minus V1 divided by R2. Then, sorry, this one V1, V3, V1, V3. So this one is also R2. Then we have the 3 to 2. So we have the V3 minus V2, 3 2 divided by R3. And then we have the V goes from 3 to 4. It's going to be V3 minus 0 because the 4 is the reference. And we have the R4. And it's going to become 0. So now we have two equations, three unknown. So V1, V2, V3 are unknown, but we have only two equations. And we already use all the nodes we have. We use V1 and V2 as a part of the supernode. We use the V3 here, and we set the V4. We set the 4 as a reference. So we already used all the nodes we had. So we cannot use any KCL for any other nodes. So because of that, again, we have to go ahead and try to find one other relationship that is not coming from the KCL. So if you look at here again between V1 and V2, if I draw that, one thing I could say is that I have the V1, then I have positive, negative, 10 volt, and it's going to be V2. So if you look at here, the V2 plus 10, because it goes from negative to positive. So in other words, V1 minus 10 is going to be V2 for this specific case that we have, or V2 plus that. This is going to be our third equation. This is going to be our third equation. So it gives us the first equation, the second equation, and it's going to be the third equation here, and that we have. And then we can use these three equations to solve it. So we have one equation for the supernode, one equation for that node 3, and one equation between V1 and V2 that are connected at the both sides of the battery. And then we will solve them to get the equations. And basically, we cannot write any other equation there.